For decades, the Saffir-Simpson hurricane wind scale has stood as the barometer of hurricane intensity. Its 5 categories, a stark classification system for these devastating storms. Each category from 1 to 5 represents a significant increase in wind speed and potential damage, providing a crucial framework for understanding and preparing for these natural disasters. Yet, as the planet warms and our oceans churn with increasing energy, scientists and meteorologists are sounding the alarm. A new breed of storm is brewing, one so powerful it dwarfs even the most intense Category 5 hurricanes. This alarming trend is driven by the relentless rise in global temperatures, which in turn heats the oceans, providing more fuel for these monstrous storms. This is the terrifying reality of the ultra-intense Category 6 storm, a hypothetical classification that reflects the growing potential for storms of unprecedented magnitude. These storms are not just stronger, they are more unpredictable, with the capacity to change course suddenly and intensify rapidly, leaving little time for preparation or evacuation. The very notion of a Category 6 storm sends chills down the spines of even the most seasoned hurricane experts. The potential for such a storm to cause unprecedented destruction is a sobering reminder of the power of nature and the fragility of human infrastructure. It represents a quantum leap in destructive power, a force of nature unlike anything we've witnessed before. The damage from such a storm would be catastrophic, with entire communities potentially wiped off the map and the economic and human toll unimaginable. While the Saffir-Simpson scale currently caps out at sustained wind speeds of 157 miles per hour or higher, a Category 6 storm could theoretically unleash winds exceeding 200 miles per hour, turning buildings into rubble and flinging cars like toys. The sheer force of these winds would make it nearly impossible for any structure to withstand the onslaught. The potential consequences of such a storm are staggering. Beyond the immediate physical destruction, the long-term impacts on infrastructure, economy, and human lives would be profound. Recovery efforts would be monumental, requiring unprecedented levels of coordination and resources. Coastal communities, already vulnerable to the increasing frequency and intensity of hurricanes, face an existential threat. These areas, often densely populated and economically significant, would bear the brunt of such a storm, with potentially devastating consequences for their residents and economies. Major cities like Miami, New Orleans, and even New York City, with their dense populations and critical infrastructure, could be pushed to the brink of collapse. The impact on these urban centers would be felt far beyond their borders, affecting national and even global economies. The emergence of the Category 6 storm is not simply a matter of scientific curiosity. It is a stark warning, a wake-up call to the very real and present danger posed by climate change. It underscores the urgent need for action to mitigate the effects of global warming and to prepare for the increasingly severe weather events that lie ahead. As we continue to pump greenhouse gases into the atmosphere, we are fueling the engine of these superstorms, setting the stage for a future where catastrophic events become the norm. The choices we make today will determine the severity of the storms we face tomorrow, and the time to act is now. The science behind the potential for ultra-intense Category 6 storms is complex but clear. These storms, which are more powerful than anything we've seen before, are a direct consequence of the changing climate. At the heart of the matter lies the undeniable reality of climate change, driven primarily by human activity. The Industrial Revolution marked the beginning of an era where human actions started to significantly alter the Earth's atmosphere. The burning of fossil fuels, deforestation, and other industrial processes release vast amounts of greenhouse gases, such as carbon dioxide, into the atmosphere. These activities have been accelerating over the past century, leading to unprecedented levels of these gases. These gases trap heat from the sun, leading to a gradual but relentless warming of the planet. This phenomenon, known as the greenhouse effect, is the primary driver of global warming. This warming effect is particularly pronounced in the Earth's oceans, which absorb the vast majority of the excess heat. The oceans act as a massive heat sink, but this comes at a cost. As ocean temperatures rise, so too does the amount of water vapor that evaporates into the atmosphere. This increase in atmospheric moisture is a critical factor in the formation of more powerful storms. This increase in atmospheric moisture provides the fuel for hurricanes, which are essentially heat engines that thrive on the energy released when water vapor condenses. The more moisture available, the more energy these storms can harness. Warmer oceans also provide more energy for hurricanes to draw upon, leading to more intense storms with higher wind speeds, heavier rainfall, and greater storm surge. This means that the damage potential of these storms is significantly increased. In essence, climate change is creating a perfect storm for the development of ultra-intense Category 6 events. These storms are not just a theoretical possibility, they are becoming a reality. The link between climate change and hurricane intensity is no longer a matter of debate, says Dr. Carey Emanuel, a leading hurricane expert at MIT. His research has shown a clear correlation between rising sea surface temperatures and the increasing power of hurricanes. The science is clear. Warmer oceans mean more powerful hurricanes. It's basic physics. The energy that drives these storms comes from the heat in the ocean, and as the oceans warm, the potential for more destructive storms increases. The increasing frequency and intensity of extreme weather events, such as hurricanes, heat waves, and droughts, are among the most visible and destructive consequences of climate change. These events are not isolated. They are interconnected and often exacerbate each other. These events serve as stark reminders of the interconnectedness of our planet's systems and the profound impact human activities can have on the delicate balance of nature. The choices we make today will determine the severity of these impacts in the future. Imagine a wall of water, towering several stories high, crashing inland, swallowing entire coastal communities. The sheer force of this surge would be enough to obliterate everything in its path, leaving behind a landscape that is unrecognizable. Picture winds exceeding 192 miles per hour, ripping apart buildings, uprooting trees, and transforming everyday objects into deadly projectiles. These winds would not just damage structures, they would completely dismantle them, turning homes and businesses into piles of rubble. This is the raw, untamed power of an ultra-intense Category 6 storm, a force of nature that defies our current understanding of hurricane intensity. Such a storm would be a cataclysmic event, reshaping the geography of entire regions and altering ecosystems permanently. While the exact characteristics of a Category 6 storm remain theoretical, scientists have developed models that paint a terrifying picture of their potential power. These models suggest that the energy released by such a storm would be equivalent to multiple atomic bombs, highlighting the urgent need for advanced research and preparedness. These storms could generate sustained wind speeds of 200 miles per hour or higher, with gusts potentially exceeding 250 miles per hour. The impact of such winds would be catastrophic, causing widespread destruction and making it nearly impossible for any structure to remain standing. To put that into perspective, the most powerful tornado ever recorded, the Bridge Creek Moore tornado of 1999, had estimated wind speeds of up to 302 miles per hour. However, unlike a tornado, a Category 6 hurricane would sustain these extreme winds over a much larger area and for a much longer duration. The storm surge, the wall of water pushed ashore by a hurricane's winds, could reach unprecedented heights, potentially exceeding 25 feet. This surge would not only flood coastal areas, but also erode shorelines, destroy habitats, and contaminate freshwater supplies with saltwater. To put that in perspective, Hurricane Katrina's storm surge reached 28 feet in some areas, devastating coastal communities along the Gulf Coast. The damage from a Category 6 storm surge would be even more extensive, affecting a broader area and causing long-term environmental damage. A Category 6 storm surge could inundate vast swaths of coastline, turning once thriving cities into underwater ghost towns. The economic impact would be staggering, with billions of dollars in damage and years of recovery efforts required to rebuild. Rainfall amounts would be equally staggering, potentially exceeding 40 inches in some areas. This deluge would lead to flash flooding, overwhelming urban drainage systems, and causing rivers to burst their banks. Such torrential downpours would overwhelm drainage systems, causing widespread flooding, landslides, and mudslides. The ground, already saturated, would give way, leading to further destruction and making rescue operations even more challenging. Rivers and lakes could overflow their banks, inundating inland areas far from the coast. This would expand the disaster zone, affecting communities that might not have been prepared for such extreme weather conditions. The sheer destructive potential of a Category 6 storm is difficult to comprehend. It would not only devastate the immediate area, but also have far-reaching effects on the economy, environment, and public health. It would be a natural disaster of unimaginable scale, pushing the limits of our infrastructure, our emergency response capabilities, and our very resilience as a species. Communities would need to come together like never before, relying on both local and global support to recover and rebuild in the aftermath of such a catastrophic event. The open ocean, a realm of unpredictable fury and awe-inspiring power, holds the key to understanding the true potential of Category 6 storms. Sailors, those who brave the high seas, have long whispered tales of monstrous waves, hurricane-force winds, and storms that defy description. Their first-hand accounts offer a glimpse into the terrifying reality of nature's untamed fury. Captain Michael, a seasoned mariner with over 30 years of experience navigating the world's oceans, recalls a harrowing encounter with a hurricane in the North Atlantic. "It was like nothing I had ever seen before," he recounts, his voice hushed with a mix of awe and terror. "The waves were towering over our ship, the wind howling like a banshee. It felt like the end of the world." His experience is not unique. Sailors around the globe have reported encounters with storms of increasing intensity, storms that push their vessels and their courage to the limit. These seasoned veterans of the sea, accustomed to the ocean's unpredictable nature, are now expressing concern over the changing patterns they are witnessing firsthand. "We're seeing storms now that we never used to see," says Captain Sarah, a cargo ship captain who has spent over a decade navigating the Pacific Ocean. "They're stronger, they're more unpredictable, and they're lasting longer. It's like the ocean is angry." These first-hand accounts from those who live and work at sea serve as a stark reminder of the power and unpredictability of nature. They also underscore the potential consequences of climate change, as rising ocean temperatures fuel the intensity and frequency of extreme